Now we're maybe on the cusp in the next few years, 5, 10 years, of having AI systems that can truly create around your imagination, sort of dynamically change the story and storytell the narrative around and make it dramatic no matter what you end up choosing.
Demis Hassabis isn't just building AI. He's building a system to reverse engineer reality itself. In this conversation with Lex Fridman, he lays out a roadmap that blurs the line between computation, physics, and life. And it's one of the most profound visions for the future I've ever heard. Let's start with the foundational idea he dropped in his Nobel Prize lecture, a conjecture so bold it reframes our entire relationship with the universe and our ability to understand it.
In your Nobel Prize lecture, you propose what I think is a super interesting conjecture that, quote, any pattern that can be generated or found in nature can be efficiently discovered and modeled by a classical learning algorithm. What kind of patterns or systems might be included in that? Biology, chemistry, physics, maybe cosmology, neuroscience? What are we talking about?
Sure. Well, look, I felt that it's sort of a tradition, I think, of Nobel Prize lectures that you're supposed to be a little bit provocative, and I wanted to follow that tradition. What I was talking about there is if you take a step back and you look at all the work that we've done, especially with the AlphaX projects, so I'm thinking AlphaGo, of course, AlphaFold, what they really are is we're building models of very combinatorially high dimensional spaces that, if you try to brute force a solution, find the best move and go, or find the exact shape of a protein, and if you enumerated all the possibilities, there wouldn't be enough time in the time of the universe. So you have to do something much smarter. And what we did in both cases was build models of those environments, and that guided the search in a smart way, and that makes it tractable. So if you think about protein folding, which is obviously a natural system, why should that be possible? How does physics do that? Proteins fold in milliseconds in our bodies. So somehow physics solves this problem that we've now also solved computationally. And I think the reason that's possible is that in nature, natural systems have structure, because they were subject to evolutionary processes that shape them. And if that's true, then you can maybe learn what that structure is.
This isn't just a provocative statement. It's a fundamental belief that the universe isn't just chaotic and infinitely complex, but that it has a learnable underlying structure. Hassabis is arguing that processes like evolution aren't random noise generators. They are cosmic optimization engines that leave behind a pattern, a gradient that a neural network can follow. This completely reframes the P versus NP problem from a purely abstract mathematical question into a physics question. If nature can solve incredibly complex problems like protein folding in milliseconds, it implies a solution path exists. What he's saying is that AI, specifically classical AI on classical computers, might be the key to finding those paths for everything. And this isn't just theory. We are seeing the first mind-bending evidence of this in a place most people aren't looking: AI video generation.
But again, if you look at something like VO, our video generation model, it can model liquids quite well, surprisingly well, and materials, specular lighting. I love the ones where, there's people who generate videos where there's like clear liquids going through hydraulic presses and then being squeezed out. I used to write physics engines and graphics engines in my early days in gaming, and I know it's just so painstakingly hard to build programs that can do that. And yet somehow these systems are, reverse engineering from just watching YouTube videos. So presumably what's happening is it's extracting some underlying structure around how these materials behave. So perhaps there is some kind of lower dimensional manifold that can be learned if we actually fully understood what's going on under the hood. That's maybe true of most of reality.
This is the critical piece of evidence. For years, the consensus was that for an AI to truly understand physics, it needed to be embodied, a robot that could push, pull, and interact with the world. Hassabis points out that VO is challenging that entire paradigm. By just watching videos, it's learning an intuitive model of fluid dynamics, lighting, and material properties that takes human engineers years of painstaking work to program manually. This implies that reality is broadcasting its source code, its underlying rules, in every video on the internet. The model isn't just mimicking pixels, it's discovering the lower dimensional manifold, the hidden physics engine of our world. It's learning the rules without ever touching the game pieces. And if an AI can learn to simulate our world so well, the next logical step isn't just watching it, but stepping inside it.
I always used to love making, all the games I've made are open world games. So they're games where there's a simulation and then there's AI characters and then the player interacts with that simulation and the simulation adapts to the way the player plays. And I always thought they were the coolest games because so games like Theme Park that I worked on where everybody's game experience would be unique to them, right? Because you're kind of co-creating the game. Right. We set up the parameters, we set up initial conditions, and then you as the player immersed in it, and then you are co-creating it with the simulation. But of course, it's very hard to program open world games. You know, you've got to be able to create content whichever direction the player goes in, and you want it to be compelling no matter what the player chooses. And so it was always quite difficult to build things like cellular automata, actually, type of those kind of classical systems, which created some emergent behavior. But they're always a little bit fragile, a little bit limited. Now we're maybe on the cusp in the next few years, 5-10 years, of having AI systems that can truly create around your imagination, can sort of dynamically change the story and storytell the narrative around and make it dramatic no matter what you end up choosing. So it's like the ultimate choose your own adventure sort of game. And, I think maybe we're within reach if you think of a kind of interactive version of VO and then wind that forward 5 to 10 years and imagine how good it's going to be.
Yeah,
This is the future of entertainment, and potentially the future of how we experience reality. He's not talking about just making bigger game maps. He's talking about world models that are generative and responsive. The game world will be co-created in real time based on your unique choices. Every player becomes the protagonist of their own completely unique narrative. Think about the implications. A storyteller that never runs out of stories. A world that never runs out of world. This is the ultimate sandbox, powered by an AI that understands the underlying physics of reality and the narrative structures that make a story compelling. This is where the line between playing a game and living a simulated life starts to get incredibly blurry. But to build these worlds and tools, we need AI that doesn't just use algorithms, but can invent and improve them.
Interestingly, with naive sort of traditional evolutionary computing methods without LLMs and the modern AI, the problem with them, they were very well studied in the 90s and early 2000s and some promising results. But the problem was they could never work out how to evolve new properties, new emergent properties. You always had a sort of subset of the properties that you put into the system. But maybe if we combine them with these foundation models, perhaps we can overcome that limitation. Obviously, natural evolution clearly did, because it did evolve new capabilities, right? So bacteria to where we are now. So clearly that it must be possible with evolutionary systems to generate new patterns, going back to the first thing we talked about, and new capabilities and emergent properties. And maybe we're on the cusp of discovering how to do that.
This is the engine of recursive self-improvement made tangible. Traditional evolutionary algorithms were stuck in a local maximum. They could optimize, but not truly invent. What Hassabis is describing with systems like AlphaEvolve is using the vast knowledge of a foundation model to guide the evolutionary search into entirely new, unexplored territories. It's about combining the broad, pattern-matching capabilities of an LLM with the focused, optimizing power of evolution. This is how you get to emergent capabilities, how you go from bacteria to a thinking human. It's a mechanism for AI to not just get better at what it does, but to evolve entirely new ways of doing things, potentially discovering architectures and algorithms far beyond human invention. So, with this power to evolve and improve, how will we even know when we've reached AGI? Hassabis proposes a test that is far more profound than any benchmark.
One would be inventing a new conjecture or a new hypothesis about physics like Einstein did. So maybe you could even run the back test of that very rigorously, like have a knowledge cutoff of 1900, and then give the system everything that was, that was written up to 1900, and then see if it could come up with special relativity and general relativity, right? Like Einstein did.
Mhm.
That would be an interesting test. Another one would be, can it invent a game like Go? Not just come up with Move 37, a new strategy, but can it invent a game that's as deep, as aesthetically beautiful, as elegant as Go? And those are the sorts of things I would be looking out for.
I think this is the perfect definition of a true AGI test. It's not about passing 1,000 cognitive tasks. It's about a Move 37 moment for science or creativity. The ability to make an intuitive leap, to formulate a beautiful, profound conjecture about the nature of reality, or to invent a system of rules as elegant and deep as Go. This redefines AGI away from just being a powerful problem solver to being a creative partner, an engine of discovery. This is the threshold where the AI stops just answering our questions and starts asking its own, pushing the boundaries of human knowledge itself. And the ultimate question it could help us answer is the most fundamental one of all. What is life?
And so virtual cell, which is what I call the project of modeling a cell, I've had this idea, of wanting to do that for maybe more like 25 years. And I used to talk with Paul Nurse, who is a bit of a mentor of mine in biology. He runs founded the Crick Institute and won the Nobel Prize in 2001. We've been talking about it since before in the 90s, and I used to come back to it every 5 years. It's like, what would you need to model the full internals of a cell so that you could do experiments on the virtual cell, and what those experiments in silico, and those predictions would be useful for you to save you a lot of time in the wet lab, right? That would be the dream. Maybe you could 100x speed up experiments by doing most of it in silico, the search in silico, and then you do the validation step in the wet lab. That's the dream. And so but maybe now, finally, so I was trying to build these components, AlphaFold being one, that would allow you eventually to model the full interaction, a full simulation of a cell. And I'd probably start with a yeast cell, and partly that's what Paul Nurse studied, because the yeast cell is like a full organism that's a single cell, right? So it's the kind of simplest single cell organism. And so it's not just a cell, it's a full organism. And yeast is very well understood, and so that would be a good candidate for a kind of full simulated model. Now,
This is the grand synthesis of his entire vision. It starts with the conjecture that natural patterns are learnable, it builds on the success of AlphaFold, it uses the search and modeling power we've been talking about, and it culminates in the ultimate scientific prize, a fully dynamic predictive simulation of a living organism. If you can model a cell, you can begin to model the origin of life itself. You can run the tape of evolution backwards and forwards. This isn't just about curing disease. It's about answering the question, how did we get here? And what are the fundamental principles of living systems? This is where AI transitions from a tool for science to the primary medium through which we conduct science. But as we build these godlike tools, capable of simulating reality and life, it forces a profound question back on us. Is pure technological reason enough to guide us?
I think we need to approach it with whatever you want to call it, a spiritual dimension or humanist dimension. It doesn't have to be to do with religion, right? But this idea of a soul, what makes us human, this spark that we have, perhaps it's to do with consciousness when we finally understand that. I think that has to be at the heart of the endeavor.
Mhm.
And technology, I've always seen technology as the enabler, right? The tools that enable us to flourish and to understand more about the world. And I'm sort of with Feynman on this, and he used to always talk about science and art being companions, right? You can understand it from both sides, the beauty of a flower, how beautiful it is, and also understand why the colors of the flower evolved like that, right? That just makes it more beautiful, just the intrinsic beauty of the flower. And I've always sort of seen it like that. And maybe, in the Renaissance times, the great discoverers then, like people like Da Vinci, I don't think he saw any difference between science and art, and perhaps religion, right? It's just part of being human and being inspired about the world around us. And that's the philosophy I try to take.
This is the most important part of the entire discussion. After laying out a plan to essentially decode the operating system of the universe, Hassabis returns to the human element. He recognizes that technology this powerful cannot be guided by cold reason alone. It requires taste, wisdom, a humanist perspective, what he calls a spiritual dimension. This isn't a rejection of science, it's an elevation of it. It's the recognition that the why is as important as the how. As we build AGI, the goal isn't just to create a powerful intelligence, but to do so with a sense of wonder, beauty, and a deep appreciation for what it means to be human. Ultimately, Hassabis' vision is that AI is not an endpoint, but a beginning. It's a tool that will force us to confront the biggest questions we have about our universe and ourselves. The real question is, will a world where anything can be simulated and understood still leave room for mystery? Or will it just reveal a much deeper, more beautiful one? Let me know what you think in the comments. And don't forget to like and subscribe for more analysis on our AI-driven future.